Physics is an interesting subject which is very broad. Before moving to the complex part, there is needed for the beginners to learn the basic of it. In physics, different quantities are being used. Finding the weight of an object or even force exerted for an object to move are determined. Most of the physical quantities encountered in physics are either scalar or vector quantities. A scalar quantity is defined as quantity that has magnitude only. Typical examples of scalar quantities are time, speed, temperature, and volume. A scalar quantity or parameter has no directional component, only magnitude. For example, the unit of time, minutes, days, hours, and etc. represents an amount of time only and tell nothing of direction. Other examples of scalar quantities are length, temperature, volume, area, density, mass, and energy. A vector quantity is defined as a quality that has both magnitude and direction. For example, acceleration. It indicates the rate of change in velocity of an object, which includes a direction where it moves according. Other examples of vector quantities are lift, displacement, force, drag, momentum, velocity, magnetic field, and electric field.
Significant figures. Significant figures of a number are digits that carry meaning contributing to its measurement resolution. Significant figures has rules to follow. The first rule, non-zero digits are always significant. For example, 1.25 and 4.5. These numbers contain no zeros and they are non-zero digits, so they are all significant. So let's count all the significant figures. 1, 2, 3. So for the first for the first example is there are 3 significant figures. 1, 2, 3. 3 significant figures. For 4.5, let's count all the significant figures. 1, 2. There are 2 significant figures. So that's all. Period. Go. The next rule is in between zeros are always significant. For example, 70206 and 75,001. These numbers contain zeros, but the zeros are in between non-zero digits, so they are significant. Let's count all the significant figures. 1, 2, 3, 4, 5. For the first example, there are 5 significant figures. 5. 1. For the second example, 1, 2, 3, 4, 5. There are also 5 significant figures, though there are zeros in between them. The third rule is zeros that are leading are not significant. For example, 0.003 and 0.000007. These numbers contain leading zeros, thus they are considered non-significant. However, the 3 and the 7 are always significant. So let's count all the significant figures. 1. For the first example, there are only one significant figure, which is 3. And for the second example, these zeros are not significant because they are leading zeros. So the only significant figure in this example is only 7. So there are only one significant figure. So let's proceed to the fourth rule. Trailing zeros are sometimes significant and sometimes are non-significant. Trailing zeros are significant when they are not needed to hold a decimal point. For example, 8, 0, 3, 0, 0.0000. These numbers has trailing zeros but are considered significant figures. So let's count all the significant figures. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 significant figures because of the presence of decimal point. Trailing zeros are considered sometimes non-significant. For example, 830,000. This contains only 2 significant figures because there is no decimal point after trailing zeros. So let's count all the significant figures. 1, 2. There are only 2 significant figures. These trailing zeros are not considered significant because there is no decimal point after them.
After knowing the rules in significant figures, we can apply it now in an equation. For example, 60 plus 40. 60 has only one significant figure and 40 has also one significant figure. So if we add them both, 60 plus 40, the result would be 100. 100 has also one significant figure which is the same as the 60 plus 40. So for subtraction, similar rules is applied. For example, 38.1 minus 12.3. Here, we align the numbers according to its decimal places and also align the decimal point. So, 38 minus 1, 38.1 minus 12.3. So here, 1 cannot be subtracted directly. Therefore, we should borrow from 8. So 8 will be 7 and 1 will be 11. Then we can proceed already. So 11 minus 3 is equals to 8. 7 minus 2, so the point here, the decimal point will bring down. So the decimal point would be brought down. Tapos 7 minus 2 is equals to 5. 3 minus 1 is equals to 2. The answer is 25.8. This 25.8 has a 3 significant figures which is similar to the number of significant figures in the given equation. For multiplication and division, different rule is followed. The number of significant figures is dependent on the number with the lowest significant figure. For example, 62,881 divided by 91. The answer would be 648.257732. However, when rules in significant figure is used, this is not yet the final answer, since the lowest significant figure in the given is 91. So we use only 2 significant figures. The final answer would be 650. Why is this so? Because we got 650 by rounding off the 648 to 2 significant figures. For multiplication and division, different rule is followed. The number of significant figures is dependent on the number with the lowest significant figure. For example, 62,881 divided by 91. The answer would be 648.2577732. However, When rules in significant figures is used, this is not yet the final answer, since the number with lowest significant figure in the given is 91, so we use only two significant figures. The final answer would be 650. We got 650 by rounding off the 648 to two significant figures. Another example is 59,441 times 2. The answer is 118,822. However, the number with the least significant figure is 2, which has only one significant figure. So, 118,822 when rounded off to one significant figure will be 100,000. 100,000 has only one significant figure.
In Physics, numerical conversion are usually used, such as centimeters to meters, hours to second, and so on. Given the example, 1,750 feet when converted to kilometers, we first find on how to cancel the feet. In the example, we use inches over feet to cancel the feet. In 1 foot, there are 12 inches. With this, we can now cancel the feet. After getting the value, we can cancel the inches. In canceling the inches, we use centimeter over inches. There is 2.54. There is 2.54 centimeter in 1 inch. However, this is not yet the answer, so we still need to cancel centimeter. To cancel the centimeter, we use meter over centimeter. In 1 meter, there are 100 centimeter. After this, we can now to cancel centimeter. Then, converting the meter to kilometer. To cancel out the meter, we use kilometer over meter. In 1 kilometer, there are 1,000 meter. After that, we can now get the final answer, which is kilometer. By following the rules of the significant figure, we follow the number with the least significant figure, which is 1,750, which has 3 significant figures. So 0.53354 kilometers will become 534 times 10 to the power of negative 3.
electric. We are electric. 1, 2, 3, 4. Let's go. Generation of electric plant. Every time it's got a head, every time